Hi everyone, and welcome to another MMS tutorial. My name's Will, and today's tutorial will be all about the newly implemented integrator propagation features. First, I'll introduce and provide a quick overview on the available integrator models. Then we'll briefly look at adaptive time-stepping integrators, and finally, I'll show you how to set up a mission and select an integrator type. There are 4 integrator types currently available in MMS, and these are Forward Euler, Rungerkuta 4, Rungerkuta 4.5, and Rungerkuta 8.9, and I'll abbreviate Rungerkuta to RK. So the Forward Euler method is a simple first-order numerical integration method that estimates the next value of a function using the derivative at the current point. It's computationally inexpensive, but can cause slight inaccuracy and instability for highly nonlinear problems. RK4 is a fourth-order integration method that improves accuracy by calculating intermediate derivatives at multiple points within each step. It strikes a balance between computational cost and precision, making it a widely used method for medium-duration mission scenarios. RK45 is a variable step method, combining fourth and fifth-order Rungerkuta methods to estimate error using the Feldberg equations and adapt the step size dynamically. It's efficient for problems requiring high precision, such as long-duration mission scenarios. And Rungerkuta 8.9 is a higher-order method offering even greater accuracy by using 8th and 9th order Rungerkuta methods for propagation and error. It's suited for problems that demand very high precision but can be computationally intensive. For the higher order methods RK45 and RK89, we have the option to select Adaptive Scheme to allow adaptive time stepping. Adaptive time stepping dynamically adjusts the size of the time step during integration based on the behavior of the solution. When the solution changes rapidly or is complex, such as close to the perigee of an Earth orbit, the time step is reduced to ensure greater accuracy. On the other hand, when the solution changes slowly, such as close to apogee, the time step is increased to improve efficiency by reducing unnecessary computations. This approach balances precision and computational cost, making it particularly useful for scenarios such as highly elliptical orbits. So now I'm going to show you how to set up a mission in MMS and select an appropriate integrator type. So first, I'm going to create a new scenario, and I'll remove the default ground station and locator, just clean it up a bit as we're not going to use them. And I'll set up a spacecraft in a circular high Earth orbit. So if I navigate to the propagation tab, we'll see under integrators a drop down list for all 4 integrator types that I mentioned earlier. For the circular orbit, I don't care too much about accuracy. I want the mission to set up fast, so I'm going to select RK4. And here you can adjust the time step, and you can do that in all 4 integrator types. So I'm going to let that go for 1 orbit around Earth. And now if I add an impulsive burn, and let this burn put the spacecraft onto an eccentric orbit, and add a new propagation. Now for this propagation, the spacecraft is going to be on an eccentric path, so I want to choose a slightly more accurate integrator type, and for that I'm going to choose either RK45 or RK89. I'm just going to go for the 4.5 version and select the adaptive scheme, and I'm going to let that play out for 24 hours, and I'll change the color just so it's a bit easier to see. If I zoom out a bit, we can watch that mission play out. I'm just going to speed it up a bit as well. There we go. So here we can see the circular orbit, and here's the elliptical orbit. That wraps up this tutorial for today, but if you'd like to see a bit more about MMS, please check out our socials for any upcoming videos, and also our YouTube channel for any existing tutorials and feature videos. You can sign up using the link below to receive a 14-day free trial, and if you'd like to learn more about MMS, please drop us an email and we'd be happy to jump on a call with you and chat about any requirements you may have. Thank you for watching and see you in the next video.